This video is going to look at some special circumstances within slope, so looking at horizontal lines and what's their slope, vertical lines and their slope, and parallel lines and how their slopes relate, and also with perpendicular. So let's start with a horizontal line. So we should have an idea of what a horizontal line looks like. We've talked about it in a couple other capacities, but in terms of slope, a horizontal line always has a slope of 0. And in the last video for this week, the video within the video had this 0 slope, and that was because when I'm looking at this line, no matter what the 2 points are I pick, I'm never going to have to go up or down to get to it. So I'm never going to make that vertical change, which means your top number is always going to be 0. And then I can run however many I want to in either direction. So that bottom number is going to be anything. But no matter what, I'm always going to end up with 0. So because of that, no vertical change, that up and down motion, that's what's giving this horizontal line a slope of 0. So if I had find the slope of a line y equals 3, so let's say you looked at it and said, well, I know that y equals any number is always a horizontal line. You could just say m equals 0. You wouldn't even have to do anything on the graph. If you didn't know that, you would have to graph y equals 3 to figure that out. So if y equals 3, that means it's got to be right here. And y is going to equal 3 at any level of that. So that's going to be a horizontal line right there. And again, from any of these 2 points, I'm never going to go up or down. I'm only going to run an amount. So that's why the slope's 0. Vertical lines, so vertical lines go straight up and down, and they're always going to have a slope that is undefined. And here's why. So if I pick any 2 points on this line, I can go up or down anything I want. I can go down 3, I could go down 7, it doesn't matter. So you could go down any number you wanted to. But then to get from one point to another, I'm never going to have to make this vertical or horizontal change. So that's going to fill in a 0. Well, and if you don't believe me, you can put it into a calculator, but any number divided by 0, your calculator is going to give you an error. That's because it's an undefined number. We can't do that. So vertical lines have an undefined slope because of this 0 in the denominator. And again, the 0's in the denominator because there is no horizontal change, which is the run of the slope in a vertical line. So again, x equals -2 is right here, and it would be anywhere along that vertical stretch. So the slope is undefined because there's that no horizontal change. Okay? And I don't want you to get too hung up on undefined. It's a good vocabulary word to know. But if you were taking an open-ended test or quiz, and you got something like this, if you told me that the slope is not possible, can't do it, anything like that, just don't tell me the slope is 0 because it's not. Vertical lines have an undefined slope. I can't do that. Horizontal lines have a slope of 0. All right, let's look at parallel lines. So parallel lines are like railroad tracks. They never intersect. So if I have 2 lines that are parallel, they're going to have the same slope. And that makes somewhat sense because if this top line was not the same slope, eventually they would cross. So the slopes have to be the same. Vertical lines are also parallel, so two vertical lines that run, they just have no slope. So if there was a line that ran parallel to the y-axis, then they would just have a no slope. Excuse me. So parallel lines have the same slope. So how can I determine if the line 6x plus 2y equals 9 is parallel to negative 3x minus y equals 3? Well, in order to determine that, I have to figure out what is the slope of this first line and what's the slope of the second line. Now, I could do that a couple ways. You could graph both of them, and that would work. I'm going to choose to use the slope-intercept method to figure it out. So I would take the 6x plus 2y equals 9. Now what I'm going to do is just get y by itself. So I'm going to subtract the 6x. That's going to leave me 2y equals negative 6x plus 9. Then I'm going to divide by 2. I'm going to divide this whole other side by 2. That's going to give me, so we got to do this divided by 2 first. So negative 6 divided by 2 is negative 3x. And then I have to do that second. 9 divided by 2 is 4.5. Okay, so now that I have something in slope-intercept form, this number that's in front of the x is always your slope. So here the slope is negative 3. I can do that same concept with this one. So I would add 3x and get negative y equals 3x plus 3. Divide by, so this is negative 1 in front of it, divide by a negative 1. Again, do this first. It's negative 3. Do that second. And again, the number in front of your x is always your slope, so m equals negative 3. So because this slope and that slope match, the answer to this would be yes, they are parallel. If they didn't, the answer would be no. Perpendicular lines. So perpendicular lines are two lines that meet at a 90-degree angle. Okay, so they make a perfect cross. And the slopes of these, pay attention and make sure we note this. So the slopes of them are opposite reciprocals. So let's take that one at a time. So opposites means if I have a positive, the other one would be negative. If I had a negative, the other would be positive. Reciprocals are that flip. So if I had 2/3, a reciprocal of that would be 3/2. Okay, so it's that flipping of the numerator and the denominator. And the key here is it has to be both. It can't be one or the other. It has to be both of them at the time. So if one slope was a positive a or a positive number, so let's say like 5, the second would have to be a negative because the first was positive, the second had to be negative, and then you'd have to flip it. So that would be 1/5 because 5, a whole number 5 is 5/1. Okay, so opposite reciprocals is for perpendicular. So if I wanted to determine if they were perpendicular, I would use that same strategy as what I did for the parallel. So take the first equation and let's get y by itself. So I'm going to subtract x, negative x minus 15, divide by 3. I get y equals, again, take the first one. That'd be negative 1/3x, okay, because there's a 1 there. Do the second, that'd be a minus 5. Right, in the second equation, all I'd have to do is add 3x, because then I end up with a positive y, and that's what I have. So your slope here was negative 1/3. Your slope here is 3. So the question is, are they perpendicular? Well, are they opposites? One's positive, one's negative. Yes, they are. Are they reciprocals? Is 3 and 1/3 reciprocals? And the answer to that is yes, they are. All right, go ahead and pause and try these 3 questions. The first 2 are just kind of recall questions. The third one, you're going to have to do some work to figure that out. Okay, so for the first one, what is the slope of a line y equals -5? So y equals any number is a horizontal line, and that's going to be a slope of 0. What is the slope of the line x equals 4.2? Well, x equals any number is vertical, and that would mean your slope is undefined. Right? Okay, so for the next one, determine whether the following lines are parallel, perpendicular, or neither. So they're either parallel if the slope's the same, perpendicular if the slopes are opposite reciprocals, and if it's neither of that, then we would answer neither. So we got these 2 equations. I'll go ahead and put them side by side. Okay, so I'm going to add 5x here. Get y equals 5x minus 6. Okay, so that would make my slope 5. It's right there. This one, I would subtract x. Get 5y equals -x plus 5. Divide by the coefficient of 5. And I get, that would be -1/5 x, and that would be plus 1. So your slope here is -1/5. Okay, so parallel is the same. Well, that clearly is out. Perpendicular is opposite reciprocals. Are they opposites? Yes, they are. Are they reciprocals? Yes, they are. So then that would be perpendicular. Right? Let's say for hypothetical purposes, let's say this came out to be a -5. Is -5 and -1/5 still perpendicular lines? And the answer to that is no. While they're reciprocals, they're no longer opposites. Right? So that's the trickiest part with perpendicular. Very good.